All right, welcome to our new unit on climate change. Objectives. So we're going to talk about the difference between weather and climate, talk about the greenhouse effect, global warming, causes and effects of climate change, take a look at greenhouse gas and ice melt data, and then explore how we as humans impact global warming and climate change. Okay, difference between weather and climate is pretty important. They are not the same thing. So, weather is our short-term, day-to-day forecast, and it's changes in the atmosphere at a certain place and a certain time. We're looking at the precipitation and the temperature. You look outside, it's sunny, it's raining, it's snowing, it's 80 degrees. And it's reported as a temporary forecast, so like your 10-day forecast, and that's over smaller regions. Okay? Then our climate is measured as an average over a long period of time. We have 6 major climate zones: polar, temperate, arid, tropical, tundra, and Mediterranean. Here we're also looking at precipitation and temperature, and then it's reported as an average over a period of time. We're looking at a large region here. So climate is really over a long period of time. What does the weather look like in an area? The greenhouse effect. So the greenhouse effect is a natural warming of the Earth's surface and lower atmosphere. It's caused by the sun, so solar radiation that's being absorbed, so taken in, and then emitted, released back by the atmosphere. Heat is absorbed by greenhouse gases. We'll talk about what those are. And they're called greenhouse gases because they act as a greenhouse to absorb the solar energy. Let's talk about those greenhouse gases. So greenhouse gases trap the energy from the sun. They're kind of above in the atmosphere. So here's the Earth, and the atmosphere is here, kind of a blanket around the Earth. Those gases get trapped in there. Okay? Sunlight enters the Earth's atmosphere and passes through those greenhouse gases. Okay? The surface of the Earth is going to absorb that solar energy. It's going to be absorbed through pavement or grass or whatever is on the Earth, through the ocean. Some of that energy is re-radiated back into the atmosphere, so like it might be reflected, maybe by ice or something like that. Some of that energy is going to continue and go out to space. The rest of it remains trapped in that atmosphere by those greenhouse gases. And that is what causes the Earth to warm up. Kind of like I said, it's like a blanket around the Earth, but it's kind of transparent as well. Common greenhouse gases. So we talked about how they trap heat. The major ones are carbon dioxide, so like what we breathe out, water vapor, and methane, okay, which is like a waste product. They are important. They maintain a comfortable temperature on Earth. If we have too many of those gases, like we're burning fossil fuels and we're getting a lot of those gases out into our atmosphere, it's going to cause our Earth to be too warm. If we don't have enough of them, we don't have a blanket surrounding the Earth, and it's going to get too cold. So they are necessary. But just a small change in our global temperature can cause huge problems for all of us. The carbon cycle and sinks. The carbon cycle is how carbon moves between oceans, air, organisms, and rocks. Then we also have places that carbon dioxide can be stored, and they're called carbon sinks. Okay? Carbon and carbon dioxide is a major greenhouse gas that does contribute to global warming. So those carbon sinks could be anything from oceans. We can store carbon in the oceans or land, in the air as well. Okay, oceans. They're the largest carbon sink. They store as much carbon dioxide as they can, but they can't handle all of the greenhouse gases that we are emitting, by transportation and factories. When we have that increased carbon dioxide, it makes the oceans acidic, okay? And acid can be detrimental, it can be harmful to anything that lives in the ocean. Kills marine life and coral. And it can prevent some organisms from building their shells that protect them. And here are the contributors to greenhouse gases. Combustion. So combustion involves burning fossil fuels, also burning forests, like fires, wildfires. Deforestation. If we are taking out the trees, there's less carbon dioxide to be taken up by the plants through photosynthesis. So remember that plants are the opposite of us. We take in oxygen and release carbon dioxide as a waste product. Plants are awesome because they take in carbon dioxide and give us oxygen. So plant more trees, have plants in your house, it's good for you. Decomposition. So when things in the landfill or organisms after they die, as they begin to break down, they release gases while they're doing that. So also important to recycle rather than throw everything away to the landfill. Some more contributors. Cellular respiration. That's what we do. We breathe out that carbon dioxide. Well, it's a waste product. Agricultural digestion. So cows and other livestock release methane as a byproduct of their digestion. Okay, and that is a greenhouse gas. And then volcanoes. They release carbon dioxide and gas and water during eruptions. Global warming. Nowadays, we just refer to it as climate change, but global warming occurs when an increase of greenhouse gases cause global temperatures to increase. The release of these gases causes the globe to warm. Over the last 100 years, the amount released has increased, as we know. The effects of global warming. We're going to increase evaporation rates. So if you think about it, when the temperature increases, things are going to evaporate much quicker. Increase water vapor in the atmosphere, okay, with that evaporation. More water vapor, which is going to also be like a blanket to continue the warming, okay, and that magnifies the effect of the other greenhouse gases. The Arctic, so where it's really cold, is warming twice as fast as the rest of the planet. Sea ice melting. Okay, obviously if we have warmer temperatures, our sea ice is going to start to melt. Well, big deal. How does that affect us? Ice is going to reflect the solar radiation. Okay, so it's like a shiny thing. The sun comes in, and that ice reflects some of that radiation out. So if we don't have that ice there, we're going to continue to warm even more. And that means we're absorbing that heat instead of it being reflected. It's going to, again, magnify that temperature increase. It's just a cycle that keeps making things worse and worse. Okay, Arctic sea ice extent. Okay, we're going from 1978 to 2011. Okay, you can see that the amount of sea ice is decreasing exponentially very fast. We're running out of time, so we'll stop here for today.